All right. So I see Dhanushri also is here. Hi Dhanushri.
Hi, sir.
All right. So quick roll call. I see Deep, Dev, Dhanushri, Chris, Nikhil, Rehan, Ria, Ritika, Shravya, and Smarni. So, did anybody get a chance to see what we are going to cover today? Who all are there in the same WhatsApp group in the first place? I think Shravya, Dhanushri are there. Dev is also there. Hey Vishal. Okay. Yeah. So, what we're going to cover today, let's quickly look at it. Hey Rehan, hi Chris, Lorian. So, we'll talk about the unit circle theorem. We'll talk about trigonometric value of some special angles like 45 degree. And then we'll look at some of the sine, cosine and 10 value of radian measures. So that's at a high level. And let's dive deeper into it. So unit circle theorem, what exactly does it mean and what does it do? Any idea? Yes, Nikhil.
Circle theorem helps you find out sectors and arcs.
So that is the circle theorem primarily from a geometry point of view. So when we talk about unit circle theorem, there is a word unit in the beginning. That makes it a little different. And that switches from geometry to trigonometry. So now with that clue, any thoughts? Anybody? Nobody? Yes, Nikhil.
Is it like triangles in relation, circles in relation to triangles? Like finding the area of a circle with a triangle in it?
Not really. We'll come to that. Okay, let's see what Ria says.
So for unit circle, is it like every circle has like a certain unit to it? So like for a regular, like for geometry, in the radius it would be like whatever number is assigned, but then the radius will be 1 for unit circles?
Partly yes. So let's look at it. Yes, Vishal.
Just to know, doesn't the unit circle give you sine, cos, and tan values for a number?
Right. So unit circle.
Angle.
Yes. So let's dive deeper into it. Okay. So I'm just checking who all are here right now. So okay. Now deep. Okay. Everybody is here. Pretty much everybody is here. So, and I'm hoping that everybody can hear me okay. Now, unit circle theorem basically is the next level of understanding trigonometric ratios, and we'll look at how it makes a difference to what we already know. So whenever we talk about trigonometry, right? Whenever we talk about sine, cos, and tan ratios, we know that suka to a helps us find out what is the value of sine, cos and tan of any angle, right? That's how we remember that. Okay, if I have a right triangle, suka tells us if this is theta, this is 90 degree. Suka tells you what is sine theta, what is cos theta, and what is tan theta. And likewise, you can find out what is the cosec theta, which is opposite of sine, what is the sec theta, which is opposite of cos, and what is the tan theta, which is the opposite of what is cot theta, which is the opposite of tan. Now, this works perfectly fine till this theta is less than 90, okay, or up to 90. This works fine. As soon as your theta becomes greater than 90 degree, then this whole right triangle concept goes for a toss. Are we saying that we cannot find sine of 120 degree? Because initially when we talked about sine, cos and tan ratios, we said okay, this is with respect to a right angle triangle. Now as soon as you are talking about sine 120 degree, you are talking about one of the angle is more than 90 degree. And if one of the angle is 120 degree, this is no more a right angle triangle. Yes, Sarah? Correct? So the whole concept that we had learned about trigonometric ratios, about the value of sine, cos and tan, has a limitation with respect to the angle being up to 90 degree. Even 90 degree is debatable, because when you are talking about this being 90 degree, you are looking at this angle, not this angle. And if you have two angles 90 degrees, it's no more a triangle, because third angle becomes 0. So unit circle helps you to talk about sine of angles which is even more than 90 degree. And that's why it becomes important for us. Is that a good starting point?
Yeah.
Now, let's try understanding what exactly unit circle is and what does it help us achieve. Everybody with me so far, right? Everybody, when I say, includes everybody, including Smarni, Rehan, Raj, Ria, Ritika, Chris, Dave, all and everybody, right? Neil, Sarah? Okay. Now let's forget about whatever we know so far about trigonometric ratio. I'm not saying that forget it completely. Keep that information in mind. Let's look at two circles. Okay. This circle I will call it a unit circle. When I say unit circle, what I'm essentially saying is the radius of the circle is equal to 1. Be it 1 centimeter, be it 1 inch, be it 1 millimeter, be it 1 kilometer, be it 1 mile, it's 1. Okay. For sake of simplicity, not to complicate it, we'll say, let's say 1 inch. And this one is, let's say 5 inches. This is 1 inch, this radius is 5 inches. No worries so far, right? Now, let's pick up a point here on this perimeter. Let's say this is P and this center is O. Or let's say this center is A and this center is B. Okay. Now I'm talking about picking up a point here on the perimeter and one point here. This is P and this, let's say this is Q. If I join these 2 points, I see that this is my horizontal line, which is along the this one, and let's also assume that my center is coinciding with this. Let's visualize this in a coordinate plane. Okay, this is my coordinate plane where this center is the origin of the coordinate plane 0, 0. This is my coordinate of the center here. Okay. Is this okay so far? So I have drawn a unit circle and I have drawn another circle here. Here in this case of unit circle, the radius is 1 inch and the center of the circle is coinciding with the origin of a coordinate plane. So I am visualizing this unit circle in a coordinate plane where this is 0, 0 and I have taken a point P and I am trying to find out what will be the coordinates of this point P when I visualize this in a coordinate plane. So far digestible? Okay. Smarni, you are being very quiet today. So far you are able to follow whatever I am doing, right?
Yes, sir.
Shravya with me? I am randomly calling out names. I am not trying to put anybody on the spot. I am just randomly checking some of you. Okay?
Yes, sir.
Okay. Now, so this is my unit circle, meaning the radius is 1 and the center of the circle is coinciding with the origin of a coordinate plane, which is, and hence the coordinates are 0, 0. if I pick up a point on the perimeter of this unit circle and say find out the coordinates of P, you will see, okay, so any point on a coordinate plane will have x and y coordinate, x and y coordinate. Let's say this is x and y. And this point, let's say when you join center and this point, this is making angle theta with this horizontal line. Yeah? So if I have to find out the x and y coordinate, this is essentially my x-axis now. This is my y-axis. If you relate this with the coordinate plane, right? So this is my x-axis, and this is making angle theta. For us to locate a point P on the perimeter and find out the x and y coordinate of that, we are saying that this is making angle theta when I join these 2 points. Now what is the x and y coordinate? So here my y coordinate will be this length and my x coordinate will be this length. Correct? Are you guys with me so far?
Yeah.
Now my x coordinate here to here is nothing but this x value. I have given x and y coordinates as x comma y, and then my y coordinate is nothing but the value here to here. I mean the length of this line basically. Now if you relate or recollect your understanding of the trigonometric ratios, what do we know? Sin theta equal to what? If this is my theta, sin theta will be y by this. Let's say this is how much this will be. If this is 1 centimeter, 1 inch, how much this will be? This is also the radius, right? It will also be the same 1, right? So sin theta here, in case of sin theta, will be y divided by the hypotenuse, which is 1. So Kato, if you remember, this is sine. Sine is opposite side divided by hypotenuse. Opposite side divided by hypotenuse. My opposite side is y. This is my y coordinate. And by the hypotenuse, which is 1. What did we get? My y equals sin theta here. Now let's look at what is the value of cos theta in this case. Cos theta will be what? Just 1 second. To open the door. Open the door quickly. First of all, you have to put lock it and then you have to turn it off either. Sorry. Yeah. So here, coming back to this one, cos theta. This is theta. Cos theta will be, cos theta is equal to adjacent side divided by hypotenuse. What is adjacent side? This. This is nothing but the x value. Cos theta will be equal to x divided by hypotenuse, which is again 1. What did you get? X equal to cos theta, y equal to sin theta. So this value is cos theta and this value is equal to sin theta. So that becomes your x and y coordinate. Cos theta is your x value and sin theta is your y value. What did we get here? In a unit circle scenario, I mean again, let's do a recap from the beginning. We picked up a unit circle, meaning a circle with a radius 1, and we said the center of the circle is coinciding with the origin, with the center of the coordinate plane, means the coordinates are 0, 0. And we picked up a point on the perimeter P, which we are saying is making angle theta. I mean, theta could be anything. I mean, we don't know what the value of theta is, but we are saying this angle is theta. Let it be 30 degree, let it be 45 degree, let it be 60 degree, whatever it be. Okay. Now, and then we said, okay, fine. We join these 2 lines, and we are saying this is making angle theta with the x-axis. So we are trying to find out the coordinate of P on the perimeter. So what is the x coordinate? X coordinate is this much. Y coordinate will be this length. And from Sokatwa we found sin theta is this by this. This is y. Sin theta is this length by 1. So from that we found y value as sin theta, and from that we found the x value is cos theta. That becomes a thumb rule that we'll follow hereafter. So unit circle tells you that if you are looking at a unit circle, any point on the unit circle you pick up, if this is theta, x and y coordinates will be again cos theta comma sin theta. Depending on whatever is the value of theta, you will find out the x and y coordinate of any point on the perimeter. Now, before I move further, any questions with respect to what we have done so far? Yes, Nikhil.
So you said that like we put the triangle at the 0, 0 point, and that's what that coincides with the circle's middle point, right? So you said both the sides of the radius of the triangle, right? Yes?
No, not both the sides. Let me draw it again. So math is about beating the drum again and again till we digest it. Okay, now let me do a little differently. This is my coordinate plane. Yeah? Meaning this is my x-axis, this is my y-axis. No doubt so far?
No.
No. I'm saying I'll pick this as my center of the circle. Okay? And I'll take 1 unit as the radius. Be it 1 centimeter, 1 inch, whatever it is. I'm saying this one unit. And then I have drawn a circle. Okay?
Yes.
So now you know your center's coordinates are 0, 0 because this is coinciding with the center of the coordinate plane. Yeah? And you know this is 1 unit. So radius from here to here is 1. Let's say this is 1 inch. Now what we are doing? We are picking up a point on the perimeter here. Let's say it is P. And we are trying to find out that any point on the perimeter, right now I'm calling it P, I can call it Q, I can call it R, I can call it N also, which is your first character of your name, correct? So now I'm calling this point P, and I'm trying to find out what will be the coordinate of that point. When I say coordinate, meaning x and y coordinates, correct? How do we find out the x and y coordinate of any point? We say, okay, fine, I'll draw a perpendicular from here to here, here to here. So this length will be my y coordinate and this length will be my x coordinate, correct?
Yes.
Now, so I'm saying, okay, let me do one thing. Let me join these 2 points. This is, let's say, O and this is point P. Now, I see that this line is making some angle with the horizontal or the x-axis, correct? Let's say this angle is theta. Now, this theta will help me find out the value of x and y. See, this is unit circle, meaning this radius is 1, this radius is 1, this radius is 1, this radius is 1. Every point on the perimeter, if you join, this length will be 1 only. Right? Because it's a unit circle. Right?
Yes.
So now I have this length as 1, and if I visualize this part, let's say this is, when I drop the perpendicular here, let's say this is A, and when I drop the perpendicular here, this is B. So right now I'm focusing only on this triangle, the shaded triangle, okay? O, P and A. In this triangle, what do I see? Since I have dropped a perpendicular, that means this is 90 degrees. Now this is a classic right angle triangle, correct?
Yes.
So from this right angle triangle, I am trying to relate x and y with theta. This length, this vertical, this side, the height of this right angle triangle that you see is y, which is my y coordinate as well. And this horizontal side of this, the adjacent side of this right angle triangle is going to be my x coordinate as well, right? Because this is the coordinate plane. This is your x coordinate, this is your y coordinate. Correct?
Oh, yeah, that's why it's sine cos tan.
Yes. So now look at x and y. What we are trying to do here is, okay, how do I relate x and y with a theta? So we know that, okay, simple. Sine theta is nothing but, if I have a theta here, sine theta is equal to the side opposite to that, divide by hypotenuse. So sin theta is equal to side opposite to that is y. Divide by hypotenuse, which is nothing but my radius, which is 1. So I'll keep sin theta equal to y, or y by 1, which essentially means y. Similarly, what is the value of cos theta? Cos theta is equal to the adjacent side divided by hypotenuse. Adjacent side is your x. What is the hypotenuse? 1, which is the radius again. Yep. So from this, we found that my y is equal to sin theta, y is equal to sin theta, and x equal to cos theta. So whenever you talk about any unit circle, pick up any point on the unit circle. Its x coordinate will be cos theta and y coordinate will be sin theta. So hereafter, whenever we talk about any unit circle, I will not write x and y. I will say my x coordinate is going to be equal to cos theta and my y coordinate is going to be equal to sin theta. Okay? Now, if your theta changes to 30 degree, you will put x coordinate value will be cos of 30 degree and y coordinate will be equal to sin of 30 degree. Okay? If my theta changes to 60 degree, if somebody says, okay, find out the x and y coordinate of point P where it's making 60 degree, I'll put theta equal to 60 degree. So what is the value of cos 60 degree? That will be my x coordinate. What is the value of sin 60 degree? That will be my x coordinate. That will be my y coordinate. Is that clear?
Yes.
Everybody clear?
Yes, sir.
Rehan, Smarni, Shravya, Dhanushri, Neil, Sarah,
Yes, sir.
Ria, everybody? Okay. Now, and now you will let's look at some interesting part of it. So if you talk about, let's say, let me clean it up. So hereafter, any point on the unit circle, if I have a circle cannot be this small, let it be a little bigger circle. While teaching you guys, one skill I have developed is I'm able to make decently good circles. So I mean, again, this is not a perfect circle, but okay, acceptable. Now, any point on the unit circle, if you talk about any point on the perimeter, if you pick up, you will say the x and y coordinates will be cos theta, comma sin theta. Okay. So, and this helps you find out the value of different angles. Let's look at it. If I say find out, okay, I believe you guys have, most of you were there in the previous classes where we found out the value of some commonly used angles, sine, cos, tan. We found out the value of 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. These are most commonly used angles, and we derived also how those values are arrived at. Okay? So I'm just filling the table right now. Some of you who were not in those classes might probably think how these values were derived and why sir is kind of asking us to memorize this. Do you know how to memorize? We have learned this, and since you will use this more often, you'll end up memorizing it. But I'm just putting the values for now, because so that we can look at some interesting facts about it. Sin 0 is 0, cos 0 is 1, tan 0 is sin by cos. That will be 0 by 1, will be 0. Sin 30 is 1 by 2, cos 30 is root 3 by 2. This becomes 1 by root 3. Sin by cos is 10. Sin 45 is 1 by root 2, cos 45 is also 1 by root 2, and tan 45 is 1. Sin by cos. Sin 60 is root 3 by 2. Cos 60 is 1 by 2, this becomes root 3. Sin 90 is 1, cos 90 is 0, this becomes infinity or undefined. These are the standard values, and we have I'm not asking you guys to memorize this, we have also seen how to get these values, okay? But I'm just putting it here for the sake of calculation. Now, if somebody says, find out the value of sine 30 degree. You have this value here, okay, and you can relate that with the unit circle, and there also you can find it out. If somebody says find out the value of sine 45 degree, you can do that in a unit circle also. Let's make 45 degree here, this angle, and then it meets a point P, or let's say this is P, I'm saying this point is Q. So what you have to do is you have to draw a perpendicular. When you draw a perpendicular from here, from this point Q, this angle also will be 45 degree, because since this is a 45 degree angle, this also will be 45 degree, because you are dropping a perpendicular which will be 90 degree. So the only angle remaining would be 45 degree only. Now if it's 45, this is an isosceles triangle. That means this side and this side will be equal. Is that understandable so far?
Yeah.
I'm looking at a 45 degree angle, okay? I'm just trying to find out the value of sine 45 degree. I'm just going to relate with this value that you see here. Now, in the same unit circle, I picked up a point Q. And from that we know that, okay, my x coordinate, this will be equal to sine 45 degree. Y coordinate will be equal to cos 45 degree. Oh, my bad. X coordinate is cos 45 degree and y coordinate is sine of 45 degree, like any other point on a unit circle. And we don't know what is that value. But here, if this is 45 degree, this is 45 degree, and this is a classic case of a isosceles triangle, meaning this x and y coordinate are same. That's what you see here in this case also in the table. But now let's prove it. This length is 1. Now let's say this is x. If this is x, this value will also be x. I mean, though it is y coordinate value, let's not say x. You guys will get confused. Let's say this is L. So this will also be L, because this is isosceles triangle. This angle same, so this side and this side will be the same. So now here what we see is L squared plus L squared equal to 1 squared. This is what Pythagoras theorem says in case of a right angle triangle. Right? A squared plus B squared equal to C squared. Here A and B are the two sides which is making 90 degree angle. Since these two are same, so you are saying L squared plus L squared equal to 1. So 2L squared equal to 1, L squared equal to 1 by 2, L becomes square root of 1 by 2, which is 1 by root 2. That's exactly what you saw here. Same way, we can prove the other values also using this or using some other technique, like what I have done before. So I'm not going deep into that, but I'm saying from this unit circle also you can find out the value of the commonly used ratios for these angles for sine, cos and tan. Is that making sense so far, or I'm just rushing through it? Okay. So Chris, you have disconnected and joined so many times. Are you able to hear me okay so far?
Yes, sir. I'm traveling. I'm in a car outside right now, and I'm having some bad internet connection.
Okay.
So the voice keeps dropping, so I need to disconnect and rejoin.
Okay, but you're able to follow me so far, right?
Yes, yes.
Okay. Now, what we wanted to do was not to go back to this table one more time. We just looked at how we can use unit circle to find out the value of sine and cos 45 degree also. Just an example. Likewise, we can find out these values also using the unit circle. But that is not the intent. Because unit circle is not a repeat of what we already know with respect to trigonometric ratios. It gives you some extra ability with respect to finding out. If I say find out the value of sine 210 degree, cos 270 degree, tan 225 degree. We all know sine, cos and tan with respect to a right angle triangle. Any right angle triangle will not have these fancy angles. How do we find it out? It's interesting, right? Anybody have any clue, or anybody wants to guide me how to find these out based on your prior experience? Dev, Aryan, Nikhil, Spanni, Ritika, Chris, Neil, Sarah, Savya, anybody? Vishal? Riya? No? Okay.
Are you telling us to solve them?
Yeah, I'm trying to find out the value of sine to 110 degree. How do I find it out?
Oh.
So, okay. Yeah, Nikhil.
You have to first find theta and then divide them by theta.
So, I'll tell you what is my current dilemma, okay? I know that SOHCAHTOA works best with a right angle triangle. When I'm talking about a right angle triangle, the biggest angle that I have is 90 degree. How do I get this guy? Right? So that now let me not trouble you guys much. Let's go into the purpose for which we are doing this class right now. So I'm just wiping it off. We'll pick up the angles based on what we feel like. Yes, somebody raise hand. Who is it? Yes, Vishal.
I think I know how to find sine of 210.
How do you do that?
So, I remember in the chart, 30 degrees is equal to 1/2.
Mm-hmm.
So,
30 degrees is
and
1/2.
200
Oh yeah, sine 30 is 1/2. Yeah, you're right. Yeah.
And then 200, so since we're finding sine 210 divided by 30,
Uh-huh.
we just go like seven times, like rotating like that. So from the first quadrant to second, to third to fourth, then fifth and sixth, and like just rotating.
Mhm.
And at the seventh one, you'll be at the fourth quadrant, and since you're finding sine, it'll be negative 1/2.
Yeah. You have kind of explained that. Let me make it more methodical here, okay? So this is where unit circle comes to our rescue, okay? So this is my unit circle. Okay? Now we'll use two concepts, unit circle and SOHCAHTOA combined to find out value of those fancy angles. Now look at, let's say 210. First try to visualize where 210 would be. This is 90, 180. 210 will be somewhere here. Meaning after 180, another 30 degrees. So this becomes my angle for which I am trying to find out the value of sine 210. Other thing to remember is, we know that any point on the unit circle says the x and y coordinates are cos theta, sine theta. The way we will deal with this is going to be, we'll use unit circle to find out which quadrant it is falling in. And let's say if I'm talking about this quadrant, that means my x and y, both the values will be negative. What will be the absolute value? We'll find it out and then put a negative to that, because my x and y coordinates are negative. If I'm talking about, let's say 145 degree, I'm in second quadrant. So where I see that my y coordinate will be positive and x coordinate will be negative. That's what you see from this coordinate plane also, right? So now here we are in this situation. We are in the third quadrant where my x and y coordinates both will be negative. So like what Vishal was saying, I will try to find out which quadrant I am falling in. So let's say we are in this quadrant. Here, my right angle triangle, if I from this point I drop a perpendicular here, this is 90 degree. This is my right angle triangle which is upside down. This is my right angle triangle which is upside down. But still, I know that this is 1 unit. So if I find out my x coordinate and put a negative to that, that will be my value of sine 210 degree. Here, let's not worry about 210. Let's look at this small triangle here, which is in third quadrant. If I just look at the absolute value of this one, I can imagine this to be same as the first quadrant. Let's forget about the sine part of it. This is my right angle triangle, and in this one, if I have to find out the x coordinate, which is here to here, cos theta, this divided by this will be cos theta, and this angle is essentially 30 degree. So this will be equal to cos 30 degree, which is root 3 by 2. And how will the angle come into picture here? Now you will get the value of this 30 degree, but you know that this is the third quadrant. So whatever is the value of x, that has to be negative. So this cos 30 is root 3 by 2, but when I am talking about cos 210 degree, I have to put a negative to it. Whatever is the value, this is the negative side of x. So minus root 3 by 2. Now similarly, this length divided by hypotenuse, which is 1. Y divided by hypotenuse is equal to sine 30 degree. So whatever is the value of sine 30 degree, I will find it out 1 by 2 and put a negative to it, because this is negative value of y. Whatever value of y we are getting, this in this quadrant, x and y, both the values will be negative. So the unit circle helps you find out which quadrant your angle is falling in, and then find out the absolute value, and based on the quadrant's behavior, you will put a positive or negative sign against that. So that way, we are not constrained by the fact that my triangle is right angle triangle, so I can only find up to 90 degrees. Here you can keep rotating it, and your SOHCAHTOA knowledge and unit circle understanding combined helps you find out the value of larger angles also. So if somebody starts thinking about a very fancy situation, you have to find out the value of cos 765 degree. We have never drawn an angle like that, but unit circle tells you that okay, don't worry. 765. How many? See, one complete circle is 360. 765 means you have to make two complete circles. That will get you 360 plus 360, which is 720. So if you have to find out the value of 720, you are just making two complete circles and coming to this point. That's it. To find out the value of 720 degree, you are just making two complete circles and coming back to this point. It is as good as the 0 degree. And then you know your x coordinate will be equal to the radius of this, and your y coordinate will be 0. So that part is understood. Now you are talking about 765. So basically you are making two complete circles and then adding 45 more degrees. So your total goal is to find out the value of this 45 degree. That's it. If you find out the value of 45 degree and you know that this is in first quadrant, your x and y value both has to be positive. So 765 is same as 45 degree basically. So unit circle helps you visualize that kind of fancy angles that we deal with. Is this part okay so far?
Yeah. Yeah, it makes sense.
Yep. So Sabia, Rehan, Neil, Sarah, Ritika, everybody okay? Ardian has been very quiet. Dave has been very quiet. Are you guys okay as well? Clear so far? Okay.
Yes, sir.
Yes, sir.
Okay. Now, unit circle is unit circle, no question about it. But are we going to deal with only unit circle on this? Probably not. Now let's look at a situation where my circle, I have a circle, but that is not essentially a unit circle, a regular circle, which has a radius, let's say 10 centimeters. So it's a regular circle which has a radius 10 centimeter, meaning here to, and again we will visualize that in a coordinate plane where the center is coinciding with the origin of the coordinate plane. And this radius from here to here is, let's say r, or say radius is 10 centimeter. In that case, if somebody says find out the x and y coordinate of point P on the perimeter, which is, let's say, 60 degree, or let's say theta only. Find out the coordinate of this point P in this situation. So if this is 10 centimeter, or let's say this is r, I'm just giving it a variable name, r. So this is also r. If you have to find out the x and y coordinate of this one, same thing you will do, nothing different. Drop a perpendicular, this is 90 degree. Now here let's say this is y and this is x. We are trying to find out x and y value. X and y value we are trying to find out. Here what will happen? Y divided by r will be equal to sin theta. X divided by r will be equal to cos theta. Yeah. So your y value is equal to r sin theta. X value is equal to r cos theta. Okay. So here my x and y value would, I can replace, x value I can replace with r of cos theta, and y value I can replace with r of sin theta. So this is a more generic form of a circle theorem. This is not a unit circle theorem. What comes into play with unit circle theorem is, you are saying, see, it's simple, it's very simple, right? It's a more generic form. Any circle with a given radius, of r, your x and y coordinates, any point on the perimeter, the x and y coordinates will be r cos theta and r sin theta. If you make this a unit circle, your radius becomes 1. This gets replaced with 1. If it's not a unit circle, if the radius is 5, this gets replaced by 5. Done deal. So, a unit circle, again, it makes a little bit of noise around it, as if it's a new or complex concept that we are learning, but that is not the case. We are actually combining 2-3 things together. We are combining the coordinate plane, we are combining the basic geometry, and we are combining the trigonometry all together to make a byproduct of the 3 things together. That is exactly what is unit circle theorem. That helps you find out the x and y coordinate or the value of different angles, regardless of being worried about the limitation that SOHCAHTOA offers with a right angle triangle. So, if somebody says find out the value of 3600 degree, you don't have to start scratching your head, because scratching your head is very dangerous. You'll end up losing hair like me. Coming back to a serious point, you have to just visualize this, that how many rounds you have to make here to get to this. 3600 is nothing but 10 rounds of 360. So you are coming back to the same point. You are essentially talking about 0 degree. Find out the value of 10 0 degree, that's what the answer is. And it also helps you find out whether it be positive or negative. So basically your circle helps you visualize that, okay, your x and y coordinates you will verify looking at the triangle that the right angle triangle that you are eventually forming. But then whether it will be positive or negative, that will be a function of which quadrant it is falling in. And in that quadrant, am I talking about the y value? Am I talking about the x value? And based on whether the x or y value is positive or negative, you will assign a sign to it. Does that make sense?
Yes, sir.
So mostly, there was a lot of questions around. I mean, when you guys go and try doing some unit tests in Khan Academy, you will see that there was a one unit completely dedicated for degree conversion from radian to degree to radian kind of a thing. But I'm not going there because it's fairly straightforward. 360 degree makes 2 pi radian. So 2 pi is equal to 360 degree. Now somebody says 45 degree, somebody says 180 degree, it is same as pi radian. If somebody says pi by 4, it is nothing but 180 by 4, which translates to 45 degree. If somebody says pi by 2, it is nothing but 90 degree. 180 by 2, 90 degree. So you will keep coming across questions around degree or radian, whichever form of measurement of angle you are comfortable with, you will convert into that and you can take it from there. You don't really have to worry too much about radian versus degree becoming a roadblock. You have to just know the conversion and that should be it. Yeah. Let's pick up one question I had based on just to make sure that we talk about questions which are more relevant, something that will be more appropriate that you will come across. Apart from concept, I have put a question here. I had put that in the WhatsApp group also. We'll just try doing that, and I'll actually let you guys do it to see whatever we have learned, is that enough, or is that helping us solve this kind of problem that we will eventually come across. So this is a circle. This is the x-axis, this is the y-axis, and this is a point A, this is probably a point B. It says in the xy plane above, O is the center of the circle, and the measure of angle AOB, this one, is 5 pi by 6 radians. If the radius of the circle is 6, if the radius here to here, this radius is 6, what is the y coordinate of A? You have to find out the y coordinate of A. Again, I have brought in a change for you guys. I was bothering you guys with tran. I'm saying RAN. Who wins prize or who wins medal in a race depends on who ran the best. Okay? So this is my new tagline, new story for you guys to memorize this magic wand or to keep a note of this magic wand. I'm saying ran is the magic wand. Who will win the race, who will do the best, will be a function of how he or she ran. Now, that's why I'm reading the question again and again. This question says that in this figure, O is the center of the circle, and the measure of AOB is 5 pi by 6 radians. If the radius of the circle is 6, what is the y coordinate of point A? So I would want you guys to try this and tell me, I mean, even if you find the answer or not, doesn't matter. How you are approaching this problem is what I'm interested in. You guys heard this question 2-3 times from me, right? So I'm being honest with my recommendation. I read the question multiple times. I can read one more time if you want me to. In the xy plane above, x is the center of the circle and the measure of AOB is 5 pi by 6 radians. If the radius of the circle is 6, what is the y coordinate of point A? I think I read it enough. You guys should be fine now. So I want you guys to give it a shot. At least tell me your thoughts. How would you approach this kind of a problem? Even if you get the answer right or not, I would not want to care about it at this point in time, but I would want you guys to at least tell me your approach and the thoughts around it. So Mandeep, you must be enjoying what we are doing with the senior kids. Don't get scared. We'll start your class in a little bit. We still have 8 more minutes. You still have 8 more minutes, so just stay quiet and wait for your turn.
What happened right now?
I'm sorry?
What were you saying?
No, I'm saying I have drawn this picture. This is a problem that we are trying to solve. I'm just interested in hearing what would be your approach. So I have drawn the circle. I said this is the center of the circle. O is the center of the circle. Radius is given as 6. And this line AOB is making 5 pi by 6 radians. We have been asked to find out the y coordinate of the point A.
Wait, what is making 5 pi by 6?
This line AOB, this angle that you see here. So I'm not really so very keen or eager to find out the answer. I'm more interested in hearing your approach for how you're going to solve this problem. And you guys have exactly 5 minutes to think about it and tell me the approach. So R and A. R I did. A is what I want you to do. Guys, don't make sound. There's a class going on. You guys have 5 more minutes before your class starts. So everybody got what we are trying to do, right? Sarah, Neil, Dhanushri, Chris, Smrni, Nikhil, Rehan. Yeah? Not for you guys. So I would be interested in hearing what your approach would be in the next 3 minutes. That's the time we have. And if I don't hear any convincing answers, then probably I will use the last 2 minutes to explain what my approach would be in given that scenario. Okay? Yes, dear. Class is going on. Just quietly come and sit down. Yes, Vishal.
So I know that to find degrees, you can cut to 5 pi times 5 pi by 6.
Mhm.
Convert it's radians, so you convert it into degrees. You multiply by 180 by pi, which then you will be left with pi 6 times 180, which you'll get 150 degrees.
What did I do? 30. Yeah, 150 degree. So you got this angle is 150 degree. After that, what would you do?
What are we trying to find?
We are trying to find out the y coordinate of the point A.
Oh.
So here, let me solve it for you guys. So again, this is on the approach. When we read this question, this says O is the center of the circle, this radius is 6, and this angle is 120 degree. I mean 5 pi by 6. So pi is equal to 180. So 5 pi by 6 will be 5 by 6 into 180. So this gives me 30 into 5, 150 degree. So this is yep. Yeah, Vishal.
So are we trying to find the y value?
Y coordinate of the point A. So now let me complete this one because so that everybody can follow. I'm sure you are approaching the same way. You can just verify if my approach is matching with yours or you have a different approach. So what we did was we found this angle so that we can find out this angle, because if we find this angle, then we can look at this as a right angle triangle to find out the x and y coordinate. And here in this case, y coordinate, if I have to find out, that will be a positive value because this is along the positive side of y axis. And if I am finding out the x coordinate, I'll find out this value and put a negative to it because this is along the negative side of x axis. Correct? So that will be our approach. So 150, then 30, and then you drop a perpendicular. This becomes a right angle triangle with this angle being 30 degree. And then after that, we all know how to find out the value of this and this. Again, that's why I was talking about the circle, unit circle, I mean extended version of or generic version of the circle theorem. Right? So I was saying this, any point on this is r cos theta and y. Guys, don't make any sound. The class is still going on. And this is r sin theta. Here r is 6 that is given to us. Put the value. Guys, when you enter a class, you don't have to enter with a bang. Come quietly and sit down, wait for your turn. Okay? So here, r cos theta will be my x coordinate and r sin theta will be my y coordinate. So here, whatever is the value of this, sin theta will be by this value. Sin theta will be here 30 degree, right? So 30 degree will be 1 by 2 and then r value is 6. That becomes 3, which is this height, and this is along the positive side of y-axis. So I will just leave it like this. So that becomes my answer for this situation. So again, nothing complicated, nothing cryptic here. Simple thing was, we read the question couple of times, then we started thinking about what will be my approach. Then we visualize this, okay fine, if I find out this angle, and that will help me find out this length. If I find out this length, that will be r of sin 30 degree. I mean, you can just think about it. This is r, which is 6. This by 6 equal to sin 30 degree. Find out this value and you know this is positive, so you'll keep it as is. If you're talking about this length, you'll say let's say this is y value, so this is x value. So you'll say y divided by 6 will be sin 30 degree, x divided by 6 will be cos 30 degree. And since this is the second quadrant, this will be negative. That is how you will relate it. So, did we all follow what I was doing, or I was making it more complicated for you guys?
I could understand it, but I think it was a bit more complicated.
Say that again, Nina?
I could understand it, but it was a bit complicated.
It was a bit complicated, and again, the key lies here. When you read the question couple of times, you will see that the intensity of the question becomes less, and then you start thinking about it. When you think about it and you visualize it, it will start becoming easy. And there's one other thing that you can do. What happened, Nikhil? Sad? Not you. There's not Nikhil here. See guys, just assume there's a sellotape here for you guys. I will tell you when to open it up. Okay?
Okay.
So, coming back to Nikhil, was it complicated? Did you find it complicated or it was just okay?
It was okay. It was a little complicated though. I can understand it.
Okay, so my request to you guys would be go to Khan Academy, open up this unit, which is about unit circle theorem, and try doing the unit test there. Okay, and then if you guys are facing any problem, watch the video one more time just to see what we learn in the class and see if you are able to relate that to solve the problem. If you get stuck, you know whom to catch hold of in the next class. Keep quiet till I let you speak. There is a class going on. I will let you when your class starts. No interruption without a reason. Okay? Keep quiet unless there is a life-threatening emergency for you. Yep. Yeah, Nikhil.
Is it gonna be on the YouTube channel?
Yeah, I put it on YouTube for you guys.
Okay.
Yeah. After the class I upload the video and I send the link also. So if you don't have, you are not in the WhatsApp group, you can get it from your parents. Yeah.
Okay.
Alright. So with that being said, I will let you guys go so that the younger ones who are super excited for their class are raising their hands even if I'm threatening them every 2 minutes. Alright?
Thank you.
Alright. See you guys.
Alright.
Bye bye.
Thanks, sir.
Bye bye. Bye bye. Bye bye. Bye bye.
Bye, sir.
Bye bye.
No, it's not.